Okay, so these are two-factor medication problems. The two-factor given quantity, the provider's order contains a numerator, which is the dosage of medication, and a denominator, which is time. So the wanted quantity, which is the answer to the problem, also contains a numerator, which is usually mLs, and a denominator, which is time. So that is what makes it a two-factor problem that we need to calculate out and analyze. Okay, so we're going to do an example. The provider orders heparin. Again, excuse my messy writing. 1,500 units an hour, IV. And the pharmacy comes and sends an IV bag that says, actually, let's make a bag here because it makes it a little more fun, right? And of course, I can't draw a bag either, but okay. Heparin, it says on the bag, 25,000 units in 250 ml, and it's D5W. All right, so this is what we have. So we got to figure out how to set this up. So remember how we need the given quantity, we need the wanted quantity, what's the dose on hand. Remember, we have to do the unit conversion, and then all our multiplying, dividing to get our answer. And we have to do our cross-outs. So there's two methods. There's a random method and sequential method. I seem to be doing the sequential method. That's the way I was taught to do it. So that's it's easy for me to do it this way, and that's what I'm showing you. So what is our given quantity? Our given quantity is 1,500 units an hour. And why is that the given quantity? Because that is what's ordered. So this is what's ordered. And that was another way I was taught. What's ordered instead of given quantity. What's ordered over what's on hand. What do we have available? But we're doing the given quantity is the 1,500 units an hour, otherwise known as what's ordered. Our wanted quantity. What do we want? What is it asking for? So actually I didn't write what they're asking for. So we need to calculate the IV pump. How many, let's calculate IV pump for mLs per hour. And as we know, like if we work in ICU or children's, a lot of times we can do micrograms, but for most pumps, we usually set up for mLs per hour. So that's what we want to know. So the wanted quantity is your answer, and that is going to be mLs per hour. Now we need to figure out what the dose is on hand. This is when we can go to this bag here and figure out what is important. So we have 25,000 units per 250 mLs. We don't have to really know that it's D5W. I mean, yes, if you're on the unit, you need to know that it's in the correct type of solution. But for calculating, we just need to know the dose on hand is 25,000 units in 250 mLs. So now we need to set this up. So our given quantity is our order, so that's going to be 1,500 units per hour. And our wanted quantity is mLs per hour. And I know in some of them I'll say mLs per hour that way, but it's easy if you're doing the two-factor medication, mLs per hour. Okay, so that's what I want to figure out, what's going on here. Now I need to convert. So somehow I need to get something in units here to convert. And so how many units? So I can do 25,000 units, I'm sorry. Here is in 250 mLs. Okay. And so I can right away cross out the units. Now what do I have? I have mLs per hour. So looks like I'm already there. I don't really need to do any more conversions. So I can multiply these two and get that answer, which is 15. And then I can, actually this would cross out, because if you multiply 1,500 by 250, it equals 30,000. Divide that by 25,000 units, and you're going to get 15. So that is your answer. 15 mLs per hour is what you're going to set the pump at. Okay, let's do another one. We have 500 mLs that the provider ordered of 0.5% normal saline with 20 milliequivalents of potassium, and we need to infuse over 8 hours. So how many mLs per hour do we set the IV pump? All right, so what's our given quantity? That is 500 mLs, right? Over 8 hours. That's what we have to work with. And the wanted quantity, what do we need to have? mLs per hour, it's asking. All right, so let's set up this equation here. So if we do the sequential method, which I like to do, I'm going to put 500 mLs over 8 hours is what we're asking for. And we need mLs per hour, correct? And it looks like we really already have that, so we don't need to do any further breakdown, right? Because we have mLs and when we have hours. So all I have to do is take my calculator and go 500 divided by 8 hours equals 62.5 mLs per hour. And that gives us our answer.